We are in the experimental hall of the European XFEL, where the X-rays produced by the machine reach the 6 instruments of the European XFEL. The machine starts 3 kilometers far from here. There the electrons are produced, they are then accelerated, then out of them X-rays are produced that are driven by the different instruments to do different experiments. There are 6 instruments, each of them has a different focus, but in each of them there is a sample environment where the X-ray interact on the sample under investigation to get information on the structure of this sample. From this interaction you have a image produced which is collected by one of our detectors that we will see later. These detectors are similar to cameras. They are pixelated detectors, although they have 1 megapixel detector, so not as much as normal, let's say, digital cameras you can put in your pocket. They are a bit less. They collect X-rays and not visible light. They are able to see very bright spots, but also very low luminosity, and they are fast. And this is the main thing. They are really fast. They can collect up over a few thousand images per second, and with a specific time pattern, which is a time pattern of the European XFEL. We are now going to visit the instruments, and we start from FXC, which is here, and I will lead you there. This is the FXC instrument, whose main focus is the study of fast phenomena, including catalyzation. Photosynthesis is one of the phenomena studied here, but many others also. The beam comes from there. It interacts with the sample. If you see here, we have air in front of the detector. The detector, one of the main detectors that is used to study this phenomena, is the LPD detector. It is a giant camera. You see how large the active area is here behind, protected by this layer, because these detectors are very sensitive and are one of a kind. They are really, we don't have any other. The sample produces a diffraction image which is collected by the LPD detector. The LPD detector is the largest of the pixels among the detectors we will see today. It is as large as half of a millimeter, and it is a 1 megapixel camera. It is very fast. It can collect the image every 222 nanoseconds, which complies to the frame rate of the European XFEL, to the rate the X-ray pulses come, for a total of a few thousand images per second. And now we will visit the next instrument, which is here nearby, which is the SPB-SFX instrument. This is the SPB-SFX experimental station. Here, one of the main focus is to study the structure of protein, viruses, biological samples, and similar. And very recently, actually, also COVID-19 related research has been performed. There, you see the beam comes from there. This is the sample chamber where the sample sits. The beam interacts with the sample, and the diffractive X-rays impact on the surface of the AGIPD detector, which is sitting here. The AGIPD detector is a 1 megapixel megahertz detector, as the LPD can provide a frame every 222 nanoseconds. So very, very fast, for a total of more than 3,000 frames per second. The pixel is a bit smaller with respect to the LPD. It's a fifth of a millimeter compared to a half of a millimeter of the LPD. And this populates the upstream part of the SPB-SFX beamline. There is another detector downstream, which we will go now to see. Okay, this is the Jungfrau detector. It's based downstream of the SPB-SFX beamline. It is composed of four units each half. Each unit is 500K pixels, so for a total of 4 megapixels, so 4 times as much as the AGIPD. This can also see very bright and very low luminosity spots, also detects X-rays. The main difference is that it cannot work at a megahertz rate, so it can collect 1 pulse per European XFEL train, so a total of 10 images per second. This is quite different with respect to the megahertz detector, but nevertheless it provides good performances and helps the instrument in their scientific program. This is the MID experimental station. The focus here is the study of material science. Here the detector uses the AGIPD. It is identical to the one we have just seen at SPB SFX. There are 2 of this kind in the world, 2 full size at least. It's a 1 megapixel megahertz detector able to collect frames at 4.5 up to 4.5 megahertz rate, compatible with the European XFEL time structure. If you think about this, the fact that you can collect a lot of frames per second allow the scientist to have a big number of frames per unit time. So also in the cases where the photon flux from the sample is low, you can collect the significant statistics very fast. The specificity here is that you have this detector mounted on this set of bellows. It can move back and forth, allowing different scientific application and different experimental techniques. This is the HED instrument. Here, matter is studied under extreme conditions, extreme pressure, extreme heat, a pressure like you can have at the center of the planet. This is one of the goals of this instrument. I'm standing here in front of the experimental chamber. This is why I'm dressed like that, and I'm keeping my mask on. You see, the experimental chamber is extremely well equipped with different tools. If you want to see a detector, it's there, a Jungfrau identical basically to the one I've shown you at SPB. It's put in a spectrometer position in the sense that the sample absorbs the X-ray and then emits, and the Jungfrau records them. You can also have other detectors here inside. The EPIX is another one which was never mentioned. But also there you have detector with smaller pixels and still big dynamic range. That means you can distinguish small signals from large signals. And but they, due to the European XFEL time structure and their structure, they work at 10 Hertz. So maximum 10 pulses per second can be recorded. This is the SES experiment station. One of the main focuses is to study the magnetic properties of material, which can impact, for example, on how the hard disk of your PC works. This is the SSC detector. Compared to the detectors that you have seen before, this is made for soft X-rays, while the others are made for hard X-rays. This means that this detector has to see photons that have an energy which is about a factor 10 smaller than the other ones. Therefore, the noise has to be lower. It is anyway still a 1 megapixel detector. It is fast as the other, so it runs at 4.5 megahertz rate, a frame every 222 nanoseconds. But with respect to the LPD and the AGIPD, it can get a bit more frames per XFEL pulse. LPD can get 510, AGIPD 352, DSSC can get up to 800. This is the last of our 6 instruments. It's the SQS instrument. It also uses soft X-rays from the machine. The beam comes from there, interacts in the sample chamber, and the emitted X-rays are collected on the detector, which is now sitting in this big vacuum vessel. The detector in this case is the PNCCD detector. The PNCCD detector is a 1 megapixel detector. It has an extremely low noise, so allowing to detect extremely soft X-ray photons of very low energy. It has a noise factor 10 lower than the DSSC, which we mentioned before. Although it can operate at a bit more than 100 Hertz, at the European XFEL it's operated at 10 Hertz, collecting 1 image out of 1 pulse train of the European XFEL. So this is one of the control rooms of the instruments of the European XFEL. From here inside, the scientists control all the infrastructure that is inside the hatches to perform their experiments. Here we finish our tour of the 6 instruments of the European XFEL, and in particular of the detectors that are used there to provide good output and good scientific data to the users of this facility.